Hello everyone. Today we'll be solving Cambridge IGCSE Chemistry Paper 2 Multiple Choice Extended May-June 2021 Variant 2-2. Guys, in this video we'll be solving from question number 1 to question number 20. So this is the part 1 video, guys, and the part 2 video will be released tomorrow. Guys, moving on. Question number 1. A gas is released at a point P in the apparatus shown. There is a damp universal indicator paper. Which gas turns the damp universal indicator paper red most quickly? Now we know that universal indicator paper will turn red if there is an acidic gas. So ammonia is not acidic gas. Chlorine is not an acidic gas. All right, it will rather bleach the indicator paper. So we have HCl and sulfur dioxide, which are acidic gas. Now most quickly will be done by the gas that has the lowest molecular mass. HCl has the mass of 1 plus 35.5, which is 36.5, and sulfur dioxide has a mass of 32 plus 16 into 2, which is 64. So definitely HCl will be the winner. So C, hydrogen chloride will make the universal indicator paper red most quickly. Question number 2. A mixture of colorless compound is separated using chromatography. Which type of reagent is used to detect the compounds after separation? Okay, since it is a colorless compound, we will require a locating agent once we are done with the chromatogram. So dehydrating agent, no. Locating agent, yes. Oxidizing agent, reducing agent, no. So B will be the correct answer. Guys, which statement about paper chromatography is correct? Okay, so let's see. A solvent is needed to dissolve the paper. Well, in paper chromatography, we do not dissolve the paper. Paper chromatography separates mixture of solvents. Well, paper chromatography separates mixture of solutes, so it doesn't separate mixture of solvents. All right, the solvent should cover the baseline. The solvent must not touch the baseline, because that would basically wash off the the solute that we want to test. So part D. All right, the baseline should be drawn in pencil. Yes, the baseline should be drawn in pencil, because we want to avoid the baseline from dissolving. So C. Question number 3, D is the correct answer. Question number 4. Element X has 7 protons. So guys, if we look into the periodic table, 7 protons is consisted by nitrogen. Nitrogen contains 7 protons. Its electronic configuration is 2,5. Now element Y has 8 more protons than X. Now 8 more protons, so 7 plus 8, it will be 15. It will be 15. So that will be phosphorus. Phosphorus contains 15. It has an electronic configuration of 2, 8, 5. Okay, which statement about element Y is correct? Y has more electron shells than X. Yes, definitely. We can see there is 2 electron shells, there is 3 electron shells. So A is the correct statement. Now let's see why the other statements are wrong. Y has more electrons in its outer shell than X. No, they have the same amount of electrons in the outer shell. Y is in different group of the periodic table. No, since they have the similar amount of outer shell electron, they're in the same group. Y is in the same period of the periodic table. No, Y is in the 3rd period, so definitely not correct. So 4A is the correct answer. Guys, question number 5. A covalent molecule Q contains only 6 shared electrons. What is Q? All right, so 6 shared electron, guys. Ammonia, nitrogen is bonded with hydrogen. In each one of them, there is a dot and a cross, which is shared between the nitrogen and hydrogen, and we can see that there is 6 shared electron. So guys, obviously ammonia is the correct answer. 5A is the correct answer, guys. However, let's see why chlorine is not correct, or why B, C, D are not correct. So in chlorine, one chlorine is bonded with another chlorine, so there is only a dot and cross. So there are 2 shared electrons. All right. In methane, there is carbon that is bonded with 4 hydrogen, and each bond represents a dot and a cross. So definitely that dot and a cross means there will be 8 shared electrons. And in water, we have oxygen that is bonded with hydrogen. So there is a dot and a cross. So there is total of 4 electrons. So none of them are correct. All right. Question number 6. Information about 4 substances E, F, G, and H is shown. Melting point / degree Celsius. All right. And electrical conductivity. So E, 1710, does not conduct when solid. So if this particular substance, when it does not conduct when it is solid, definitely cannot be a metal. So not a metal, we can say that. But it has a very high melting point, so we must take that into consideration as well. Melting point of 3500 degrees Celsius, conducts electricity when solid. So definitely could be definitely could be a metal, could be graphite as well, because it has a very high melting point. All right, could be a metal or graphite. All right, then this is non-metal. We can definitely say this is a non-metal. All right, and not graphite as well. For G, melting point 120 degrees Celsius, does not contain electricity. This is a molecular compound. All right, because that is such a low temperature in terms of melting temperature, and it does not conduct electricity as well. Melting temperature of 801, and conducts when molten, could be a metal, could be an ionic substance. Since it has a melting temperature of 800 degrees Celsius, 800, it could be ionic, most likely to be ionic. So guys, the question says E, F, G, H are graphite, polythene, sodium chloride, silicon dioxide, but not in that order. What are E, F, G, H? So guys, definitely 1710, however, does not conduct electricity. All right, E cannot be graphite, because graphite conducts electricity when it is solid. It cannot be sodium chloride. All right, the reason why it cannot be sodium chloride, because melting point of sodium chloride is not that high. It cannot be polythene. All right, so it can only be silicon dioxide. So E is silicon dioxide, guys. F could, yes, graphite, and G is polythene, and H is sodium chloride. So D is the correct answer, guys. Question number 7. Chemical compounds formed from a group 1 element and a group 7 element contain ionic bonds. So group 1 element and group 7 element contains ionic bonds. So let's see an example. If we consider group 1 element sodium and group 7 element chlorine, we know that sodium gives off 1 electron, forms +1, chlorine takes 1 electron, becomes -1, so it forms NaCl. So they contain ionic bond. Okay, how are the ionic bonds formed? So electrons are transferred from group 7 atoms to group 1 atoms. Well, we have already seen it is the group 1 atoms that give electrons. Electrons are not shared. All right, they are transferred to form ionic compounds. Electrons are lost by group 1 atoms and group 7 atoms. So no, both of them does not lose electron, one of them gains electron. Electrons are transferred from group 1 atoms to group 7 atoms. Yes, that is correct. So 7D is the correct answer, guys. Guys, moving to question number 8, some information about particles PQR is shown. Okay, so guys, if we see the nucleon number is 12, the number of neutrons is 6, number of electrons is 6. So guys, we can determine the number of proton, which is also 6. Nucleon number minus the neutron number, we get the proton number. So guys, let's do the same thing for other ones. 24 minus 12, it will be 12. 16 minus 8, it will be 8. 14 minus 8 will be 6. So guys, we can see that number of proton matches in this two. So P and S, they can be isotopes. They can be isotopes. Now the question says which two particles are isotopes of the same element, because they have the same proton number, guys, P and S, so they can be the isotopes. So question number 8B is the correct answer, guys. Guys, moving on. Chlorine gas will react with iron metal. Okay, so chlorine gas does react with iron metal. All right, now it can either form, according to what I know, is that it can form FeCl2 or it can form FeCl3. All right, so the question says exactly 21.3 gram of chlorine reacted with 11.2 grams of iron. How many iron atoms reacted with 30 molecules of chlorine? Interesting, guys. Guys, in a question like this, all right, definitely it would be a good idea to find out their empirical formula. So what we can do for chlorine we have 21.3. All right, and for iron we have for iron Fe we have 11.2. So what we can do, we divide it by 35.5, we divide this by 56. All right, and 21.3 divided by 35.5 gives us 0.6, and 11.2 divided by 56 gives us 0.2. So guys, we can just simply divide with 0.2 and 0.2, and that gives us a 3 for the chlorine, and that gives us a 1 for the iron. So definitely for each iron atom, all right, there is 3 chlorine atoms. Now the question says how many iron atoms would react with 30 chlorine atoms. Now we know that for 3 chlorine atoms we require 1 iron, so 30 divided by 3, which is equals to 10. So 9A is the correct. Sorry guys, one more time. uh, there seems to be some kind of mistake. 30 molecules of chlorine. All right. So guys, my bad. I got tricked a little bit because the question says 30 molecules of chlorine. 30 molecules of chlorine means Cl2. So each Cl2 is 2 chlorine atoms. So that was a trick over there. So it will be equals to 60 chlorine atoms divided by 3. All right, which is equals to 20, guys. So the answer for the 9 will be C. So guys, question number 9C. Guys, this was a relatively easy question. However, you can find it really difficult. It may prove to you very difficult. So guys, definitely I would ask you to go through the empirical formula to find out its formula, and definitely then be sure to look out for these molecules, because if it were atoms then the calculation was correct, 30 divided by 3. However, since it is molecules, so definitely each molecule of chlorine contains 2 atoms. We multiplied by 2, 30 into 2, 60, and then we divided by 3 to get 20. So we will require a total of 20 iron atoms to react with 30 molecules of chlorine. All right, so we got the trick there. That's really good. Question number 10. In separate experiments, electricity was passed through concentrated aqueous sodium chloride and led to bromide. All right, now the question is what would happen in both experiments? Guys, when we say concentrated sodium chloride, NaCl aqueous, guys, the ions are Na plus, Cl minus. The ions are H plus from the water and OH minus from the water, guys. And when we say molten lead bromide, guys, we need to understand in molten, it is a binary electrolysis. So lead bromide PbBr2, a classic example of electrolysis. There is only Pb2 plus, and there is bromide ion. Now guys, we need to understand, because we are passing electricity through a concentrated aqueous sodium chloride. Concentrated aqueous sodium chloride will definitely release, all right, chloride in the anode. All right, because it is concentrated, so the chloride has higher concentration, it gets the priority. And from sodium and hydrogen, hydrogen will be released in the cathode, all right, because it is lower in the reactivity series. But for lead bromide, all right, this bromide will go to the anode, which is very clear, and Pb2 plus will go to the cathode. Now guys, lead will be produced in the cathode. Now the question says, what would happen to both experiment? A halogen would be formed at the anode. Yes guys, we can see a halogen is formed here, the halogen is formed here, and they are formed in the anode. All right, so A is the correct statement. Let's see why the other points are wrong. A metal would be formed at the cathode. Guys, in both experiments, metals are not formed. As we can see in the experiment with concentrated sodium chloride, we got only hydrogen. So metals are not formed in both. Hydrogen would be formed at the anode. Hydrogen cannot be formed at the anode because it is a positive ion. It is repelled by the anode. It is attracted towards the cathode. Hydrogen would be formed at the cathode. Yes, however, in both experiment, we don't get hydrogen, so it's also wrong. So 10A is the correct answer. Guys, now we're going to go from question number 11 to question number 20. So let's see. Let's try a rapid fire. reaction involving aluminium is shown. We can see aluminium reacting with oxygen, reacting with water, producing aluminium hydroxide with X quantity. So the question says which values of X and Y balances the equation. Guys, whenever a question like this comes, I would strongly suggest that you go for your own independent balancing. Don't focus, write the equation one more time. It will waste a little bit of your time, but trust me, it will not get your equation messed up, and thereby you will do better. So ALOH3. Now guys, one thing that we need to remember, that X is over here and X is also over here, and for oxygen there is a Y. Now for options of Y we have 2, 3, 4. So there is a lot of options. All right. For options of aluminium, we have also 2, 3, and 4. All right. So let's see, guys. Aluminium. All right. If we were to balance for the aluminium, all right. Now let's say because we have the options for 2, if we give 2 aluminium, all right, then we'll have to put 2 over here, which means there will be 2 aluminium as well, which makes this particular hydroxide 6OH, which means 6 hydrogen and 6 oxygen. Guys, here we have 12 hydrogen. So it definitely doesn't make sense with a 2. All right. Guys, if you haven't understood the working, basically what I did was I multiplied the 2 from here, which I got from here, and then I multiplied with the OH3. So I got a total of 6 hydrogen, 2 into 3, 6. So this is definitely not working. So we'll try with X aluminium. X is equals to 4. Let's see if that helps us a little bit. So if we have 4 in the aluminium, all right, if we have 4 in the aluminium, we're going to have 4 over here, which gives us a total of 12 hydrogen. 12, 4 into 3, 12 hydrogen. We get 12 hydrogen, we get 12 oxygen. Now, to balance that out, all right, 12 hydrogen is already balanced. There is 6 oxygen over here. We require another 6 oxygen. So definitely it can be provided. So this is 3. 4 and 3 will be the correct answer, guys. Guys, if you haven't understood the working, please, see the video another time. You try it on your own as well. All right. It was a trial and error method, and you can do it too. All right, have confidence and you can do it. And these are oxygen, by the way. They do look like 120 and 60. Let's just keep it aside and move to question number 12. 4 different fuels were used to heat a beaker of water for the same amount of time using the apparatus shown. Okay, smart. 200 grams of water was taken, spirit burner, fuel. All right, screen to reduce heat, draughts, air. All right, and thermometer. Okay. We have a stirrer so that we ensure that even heating is done. The initial temperature of the water and the temperature after heating by the fuel are recorded. Which fuel releases the most heat energy? So to find out the most heat energy, we'll have to do kind of like a math. All right, highest temperature minus the lowest temperature. So 46, 46 minus 17. All right, 46 minus 17, this is 29. So let's write down all those values. 52 minus 24. All right, 28. 61 minus 26. 35. Okay, we can see big numbers here. And the last one is 32. I can just simply do it in my mind. The highest temperature change is in C. So definitely for question number 12, the answer will be C, because every other conditions were kept constant. So since this particular fuel, the fuel C, produced the highest temperature change, so definitely it produced the most amount of heat energy. All right, guys, we're moving to question number 13. An excess of calcium carbonate reacted with dilute hydrochloric acid. The volume of carbon dioxide produced is measured at a regular time interval. The results are shown in experiment 1. The experiment is repeated with only one change in the reaction condition. The results are shown in experiment 2. All right, we can see in this experiment, we have a higher volume of hydrochloric acid. We have a higher volume of carbon dioxide gas. So there is a higher volume. There is higher CO2 quantity. or the higher CO2 quantity, all right, we already had excess amount of calcium carbonate. Our dilute hydrochloric acid was the limited one. So maybe either we have increased the concentration of hydrochloric acid, or we have increased the quantity of hydrochloric acid. All right, so what change is made in experiment 2? All right, so in experiment 2, the concentration of acid is increased. Could be the volume of acid is increased. Okay, now this can be, so let's see, let's read the question. The experiment is repeated, only one change to the reaction condition. All right, so with only one change. All right, so with one change, all right, concentration of the acid is increased. The volume of carbon dioxide produced is measured. All right, so with one change to the reaction condition. Now, all right, as you can see, all right, as you can see, there is something we need to understand. If we were to increase concentration, this reaction would be even more faster. It would not be in the same rate. So since the reaction is in the same rate, all right, so it cannot be an increase in concentration. All right, it can only be an increase in volume of the acid. Guys, I am trying to, I'm helping you to understand it one more time. Since we see both of the reaction starts at the same rate, so definitely the concentration of the acid in both experiments are same. So that's why concentration of acid is increased. This particular point is wrong. The volume of acid is increased and the mass of calcium carbonate is increased. Well, no, we only used one thing, and calcium carbonate was already in excess, so will not affect. Calcium carbonate is powdered. Well, it will still not affect the final volume of carbon dioxide. So, all right. So B is the correct answer for question number 13. Guys, moving to question number 14. When sulfur is heated, it undergoes a dash change as it melts. So, since it is melting, it's a physical change. Further heating causes the sulfur to undergo a change and sulfur dioxide. So undergo a chemical change because it is forming a new chemical. It was sulfur before, now it is sulfur dioxide, which is definitely chemical. All right, so C, guys, question number 14. C will be the correct answer, guys. Moving to question number 15. 4 statements about the effect of increasing temperature on a reactions are shown. All right, so increasing temperature, the activation energy becomes lower. That is totally wrong. Catalyst decreases activation energy, guys. Nothing else can decrease activation energy, so we should keep that in mind. All right, now moving to the next point. All right, oh, by the way, if one is wrong, A and B is already crossed out. Oh, okay, that sounds like a blessing. The particle moves faster. Yes, obviously increasing temperature, the particle will move faster. There are more collisions between reacting particles per second. Yes, because the particles are moving faster, definitely, it would definitely mean that they would collide more faster. All right, there would be more collisions. There are more collisions which have energy greater than the activation energy, which is also correct. Yes, there would be more collisions with energy greater than the activation energy, because now at higher temperature, these particles have gained some energy from the temperature and they want to react even harder. All right, so 15C is the correct answer. Question number 16. An example of a redox reaction is shown. Zinc plus copper 2 plus produces Zn2 plus and copper. Which statement about the reaction is correct? Guys, when zinc is turning into Zn2 plus, it is giving off electrons, so it definitely oxidation, copper 2 plus turning into copper, that is reduction, it is gaining electron. And guys, the component that gets reduced is the oxidizing agent. We always know that it is the oxidizing agent, and the component that gets oxidized is the reducing agent, guys. We can always write this thing down to basically decrease our confusion. Zinc is the oxidizing agent, and it oxidizes copper 2 plus. All right, yes, so the question says which statement is correct. Yes, zinc is the oxidizing. Okay, by the way, zinc is the reducing agent. So no, zinc is not the oxidizing agent, not the oxidizing agent. Yes, zinc is the reducing agent. Yes, zinc is the reducing agent. All right, and it oxidizes copper. No, it doesn't oxidize copper. It reduces copper because it's a reducing agent. So D will be the correct answer. Zinc is the reducing agent and it reduces copper 2 plus. Question number 16D. Guys, 17. When bismuth chloride BiCl3 reacts with water, a white precipitate of bismuth oxychloride is formed. The equation for the reaction is shown. BiCl3 plus H2O, BiOCl 2H plus 2Cl minus is formed. Okay, the reaction is in equilibrium. Which change causes the white precipitate to dissolve? So guys, we can see, if we increase the concentration of anything from here, this aqueous, obviously we're going to shift the equilibrium towards this direction. So adding acid, definitely yes, H plus ion, we're going to increase the concentration, is going to move towards left. Adding water, well, adding water will push this towards the right direction. All right, so adding water doesn't. So number 2 is wrong. Guys, if number 2 is wrong, then we can already see A is wrong, C is wrong, D is wrong. So adding a little bit of sodium chloride solution, guys, yes, sodium chloride will increase the chloride ion, and thereby the equilibrium will shift towards this direction. So 1 and 3 is definitely correct. B is correct, guys. Guys, moving to question number 18. The element X forms an oxide, XO, that neutralizes sulfuric acid. Okay. Which row describes X and XO? So element X and nature of the XO. If element X is a metal, the nature of XO will be not acidic. If it is a metal, then it's going to be basic. All right. And it says that it neutralizes sulfuric acid. Definitely has to be basic. It cannot be a non-metal. All right. So B will be the correct answer, guys. 18B. Guys, non-metal can form acidic oxides, which is why I had to cancel them out. Question number 19. Information about the solubility of salts is shown. Or chlorides soluble except lead 2 chloride and silver chloride, nitrates soluble, sulfates soluble except barium sulfate and lead 2 sulfate. Very good. Aqueous solutions of which two compounds would produce a precipitate when added together? Guys, all right, this for some it can be a very tricky question, guys. However, guys, I would definitely ask you not to fear. Barium nitrate and calcium chloride, guys, whenever added together, let's switch. If it becomes calcium nitrate or barium chloride, guys, we can see that they are soluble. They are not in the exclusion zone. All nitrates are soluble, and barium chloride is not mentioned in the insoluble portion. So it will not be the answer. All right, we need precipitate. So when we add copper sulfate with zinc nitrate, so I think, guys, you have already got the point. It's going to be copper nitrate and zinc sulfate, guys, both are soluble. All right, potassium chloride and sodium sulfate, sodium chloride and potassium sulfate are still soluble. Lead nitrate and magnesium sulfate, guys, we are going to get lead sulfate. As we can see, lead sulfate is a solid, thereby it will precipitate. So D will be the correct answer, guys. Guys, if you have problem doing question like this, I strongly suggest that you study your acid-base salts. And in that particular part, you also get this particular note, which is called the solubility chart. Please go through that, memorize the solubility chart, and definitely you will be good to go. Question number 20, guys. This is the last question, all right, for this video. So guys, let's see. The equation shows the reaction between hydrogen and oxygen. Okay, 2 hydrogen, oxygen, 2 HOH. The bonds energies are shown. Guys, the bond energies are shown, that's really fine, but we don't usually have the bonds in hand, because here there are 2 OH in each water, so there will be 4 OH. All right, so that being cleared, now the question says which row shows the energy change and the type of reaction. All right, energy change. Obviously the energy change will be exothermic. How can we tell? Definitely hydrogen and oxygen reacting, guys, that's like literally a rocket explosion. Definitely it will be an exothermic change, but let's see the values. 436 for hydrogen, which is multiplied by 2, and for oxygen it will be 495. All right, now we're going to subtract it, and the subtraction is going to be from 4 OH is 463, guys. If we put in the numbers, 436 into 2 plus 495, which gives us a total of 1367. All right, okay, and for the other side, 4 into 463, we have 1852. Definitely an exothermic reaction, guys. So if we do the subtraction, 1367 minus 1852. All right. So 1367 minus 1852. Guys, that gives us a value of negative 485. So guys, yes, it is exothermic, but not 441. It is 485. So C is the correct answer, guys. The negative indicates exothermic. All right. Okay, guys. So guys, that's all for today's video. All right. Please keep watching my videos and subscribe to the channel. All right. And in the next video, I'll be uploading for this particular question paper 21 to question number 40. And definitely I will put them in a playlist. Guys, watch the playlist, watch the entire video, guys. And good luck with your exam. Bye bye.